So in this video, we're going to talk about using dimensional analysis to convert numbers from one unit to another. I've been referring to this as train tracks in class because it looks as if we're putting our numbers on the map symbol for train tracks. And I think calling it train tracks instead of dimensional analysis just seems a lot friendlier. So we're going to do 4 problems together in this video. The first 3 are similar to a problem or 2 that you'll have on the semester final. The last one is similar to a problem that you won't be required to do on the final, but that will be available to you to do for bonus points. These are simpler 1 or 2 step things. This has more steps. So we'll do all 4 of these together right now. The first question, convert 742 centimeters to inches. And I'm always going to give you the conversion factor on something like a test. If you are in the real world and you're looking to convert one thing to another, you can usually Google or otherwise research and find the conversion factor. But on the test, I will give you the conversion factors. In this case, 1 inch equals 2.54 centimeters. So let's start by putting the number 742 on our train tracks. We'll put the abbreviation for centimeters there. Now, we're going to put centimeters down here as well because thinking ahead, I know that I'm going to want to cancel it out. So in this section, I'm going to put an equality. I'm going to put my conversion factor. So 2.54 centimeters, 0.454 centimeters equals 1 inch. So, and that's all I need. Now I'm ready to cancel out centimeters. Multiply this across, 742 times 1, 742, times 2.54 is 2.54. I'm going to see that I only have 1 unit. I can move it over here, inch. Now I'm just going to simplify this thing. 742 divided by 2.54 is 292.13. 292.13 inches. So here's my answer. Now, if you can solve this by just knowing that you have to divide instead of putting it on train tracks, that's totally fine. I teach it this way because it's easier for me to remember whether to multiply or divide. And so I think it's going to be easier for you to remember as well. So now going on to the next one, convert 9,672 seconds to hours. Again, I'm giving you the conversion factors. In this case, there are 2 conversion factors. We could do this in 1 step if we knew that there were 3,600 seconds in an hour. But I'm going to use this as an example to show you a 2-step conversion. So I'm going to draw my train tracks. I'll start out putting 9,672 here, seconds. I'm going to put seconds down here also because I know I'm going to want to cancel this later. So let's see, 60 seconds is, well, I don't know why I put it all the way over there. 60 seconds is 1 minute. But now I don't want to end up in minutes, I want to end up in hours. I'm going to put minutes down here so that I can cancel it later. 1 minute, nope, 60 minutes is 1 hour. That's a little sloppy, but you see what I've done. Now I'm going to cancel. I cancel out seconds, cancel out seconds. I can cancel out minutes, I can cancel out minutes. Now I'm going to multiply across 9672 times 1 times 1, 9672. 60 times 60 is 3,600. You can simplify that. 9672 divided by 3,600 is 2.69. 2.69, and then the only unit that hasn't been canceled is hours. So I'm going to put this over here, hours. And here's my answer, 2.69 hours. Now, let's do something from milliliters to ounces. Now, you'll notice in class that I don't just stick with the metric system, like centimeters and milliliters, because we live in the United States, and in the United States, we still use the English system. So while in the world of science, we usually use the metric system because science is such an international discipline, the rest of the world uses metrics. So as scientists, we use metrics so as to facilitate communication between scientists. But the fact is that you and I live in the United States, and we interact with our families and our coworkers and our classmates and our teachers. And those people all don't use the metric system in day-to-day life. So I want you to be familiar with converting into and out of it, and be familiar with converting between units in the not metric system also, because while it's my job to teach you science, it's also my job to teach you to approach scientific things in the real world in a way that works also. So let's convert 643 milliliters, which is metric, to ounces, which is not metric. We'll just put these on our train tracks. 643 milliliters. Put milliliters down here so I can cancel it later. Put my equality here. 29.57 milliliters is 1 ounce. Let's see. So I'm going to cancel this. Cancel milliliters, cancel milliliters. So I'm going to take 643 times 1, 643, times 29.57 is 29.57. That was ridiculously simple, right? 643 divided by 29.57. Heck, let's do that again and actually push the numbers this time. 643 divided by 29.57 equals 21.75. 21.75. The only unit here is ounces. Move this over, ounces. So here's our answer, 21.75 ounces. As an aside, let me point out that if you are taking a test for me, and really anybody who's having you write out answers to test questions, show your work, come up with the right answer, use the correct units. All three of those things are really, really important. On the final exam, I'm going to ask you to do problems, and if you just magically come up with the right number and write it down on your exam page, you're not going to get full credit. We've talked about this lots before, but since we're studying for the test together, I feel like I should reiterate. Show your work. Give me the correct answer. Use the correct units if you want full credit on one of these questions. Now, here's one that's multi-step. I want you to know how to do this. For one thing, I just want you to know how it works. I want you to know that it's possible to do this kind of thing without asking Google or Siri or Alexa. And also, if this clicks and you can do it on the test and you have time, you'll get some bonus points. So I want to show you how to do it. Convert 75 miles per hour into meters per second. This is where the real magic of dimensional analysis shows up. The magic of the train tracks shows up, because you can convert different things at the same time. I think it's very cool. So I'm going to draw some longer train tracks this time. 75 miles per 1 hour. So let's first convert miles into meters. Let's see. 1 mile, put this down here so I can cancel it, is 1609 meters. All right. Now I want to do hours. So I'm going to put 1 hour up here. Well, 1 hour is 60 minutes, right? Okay. I'm going to put minutes up here so I can cancel it later. 1 minute is 60 seconds. So I'm deciding where to place these just because I'm looking ahead and knowing that I want to cancel them later. So I think this is all I need to do. I can check to be sure that I've done everything I need to put everything down that I need to put down by canceling. So I'm going to cancel miles and miles. Let's see, I can cancel hours and hours. I can cancel minutes and minutes. The only thing I have left here is meters and seconds. So it looks like I ought to be done. So now I'm going to multiply across. 75 times 1609 is what? 55 times 1609. Yikes, that's a big number. 120,675. And then 60 times 60, we did that up there. It's 3,600. And then we can simplify that. Let's see, 120,675 divided by 3,600, 33.52. And then move this over, meters, and I can move that over per second. So here's my answer. That whole thing gives me the answer that 75 miles per hour is the same thing as 33.52 meters per second. If you have time to work on conversions some more and this is still not going over well in your head, there are lots and lots and lots of examples of conversions using dimensional analysis that you can look up online. Let me write that down for you. Dimensional analysis. I call this train tracks, but pretty much everybody else calls it dimensional analysis. So if you want some more practice on it, Google some work on dimensional analysis conversions.